Welcome to Module 16, Network Security Fundamentals. Frame it with the on-screen line. Setting up a network without securing it is like opening every door and window to your home, then going on vacation. This module covers threats, attack types, mitigation, and actual device hardening commands, the last stretch before the course wraps. Objective: configure switches and routers with device hardening features to enhance security. Preview the topic table on screen. Security terminology/threats, network attacks, attack mitigation, and device security. This module moves from concepts to hands-on hardening commands by the end. Threat actors gain access through software vulnerabilities, hardware attacks, or guest credentials. Once in, 4 types of threats can follow, shown on screen: information theft, stealing confidential data, data loss/manipulation, destroying or altering records, identity theft, stealing personal info to impersonate someone, and disruption of service, blocking legitimate users. Each gets its own deeper slide next. Information theft means breaking in specifically to obtain confidential data. That stolen information gets used or sold. Classic example on screen: stealing an organization's proprietary R&D data, which competitors or bad actors would pay well for. 2 distinct problems here, shown on screen: data loss, destructive, a virus reformatting a hard drive, data simply gone, and data manipulation, subtle, breaking in to change records, like altering the price of an item. Manipulation is often more dangerous, since it's harder to detect than outright destruction. Identity theft is a specific form of information theft focused on stealing personal information to take over someone's identity, applying for credit, obtaining legal documents, making unauthorized purchases, all in the victim's name. Worth mentioning, this is a growing problem costing billions of dollars annually. Disruption of service means preventing legitimate users from accessing services they're entitled to. The classic example is a denial of service. DOS attack targeting servers, network devices, or communication links themselves, overwhelming them until real users can't get through. Vulnerability is the degree of weakness in a network or device. Some degree exists in every router, switch, desktop, server, even security devices themselves. 3 broad categories shown on screen: technological, weaknesses in TCP/IP, OSes, network equipment; configuration, insecure accounts, default settings, misconfigurations; and security policy, missing or unenforced organizational policy. Endpoints like servers and desktops are typically the actual attack targets. 5 common technological/configuration vulnerabilities, shown in the table: unsecured user accounts, credentials transmitted insecurely, easily guessed passwords; misconfigured internet services, like JavaScript enabled on untrusted sites; unsecured default settings, shipped in security holes; and misconfigured network equipment, bad access lists, routing protocols, SNMP strings. 6 policy-level vulnerabilities, shown in the table: no written security policy, can't be consistently enforced; politics, turf wars blocking consistent implementation; lack of authentication continuity, weak/default passwords; logical access controls not applied; inadequate monitoring lets attacks go unnoticed; software/hardware changes ignoring policy, unauthorized changes creating holes; and no disaster recovery plan, chaos when something actually goes wrong. If network resources can be physically compromised, that alone denies their use entirely. 4 physical threat classes shown on screen: hardware, physical damage to equipment; environmental, temperature/humidity extremes; electrical, voltage spikes, brownouts, power loss; and maintenance, poor handling, missing spares, bad cabling/labeling. Physical security is often overlooked compared to digital threats, but it's just as real. Malware is malicious software designed to damage, disrupt, steal, or cause illegitimate action. 3 types, shown in the table: viruses, insert into another program, spread only when the infected host file runs; worms, standalone, no host program needed, self-propagate through vulnerabilities; and Trojan horses, disguised as legitimate software, spread only through user interaction, don't self-replicate. Note, Trojans are also known for creating backdoors for ongoing access. Beyond malware, network attacks break into 3 major categories: reconnaissance, access, and denial of service, summarized on screen as discover and map, break in, and disable. Reconnaissance is the unauthorized scouting mission that precedes an actual attack. Tools like NSLookup and WHOIS help a threat actor map a target's IP address space before probing further. Reconnaissance typically unfolds in 3 stages, shown on screen: internet queries, Google searches, org websites, WHOIS lookups for initial info; ping sweeps, systematically pinging every address in a range to find active IPs, automated with tools like FPING; and port scans, probing the active IPs found to discover open services/ports. This is literally the scouting phase before a real attack begins. Access attacks exploit known vulnerabilities in authentication, FTP, and web services to gain entry to accounts, databases, and sensitive information. 4 types, shown on screen. Password attacks, guessing or stealing credentials. Trust exploitation, leveraging one compromised system's trust relationship. Port redirection, using a compromised system as an attack base. And man in the middle, intercepting data between 2 legitimate parties. 3 password attack methods shown on screen. Brute force, systematically trying every combination until one works. Trojan horse attacks, malware disguised as legitimate software capturing credentials as entered. And packet sniffers, capturing network traffic hoping to catch plaintext credentials. Each represents a different angle, guessing, tricking, or intercepting. In trust exploitation, a threat actor compromises an easy target first, then leverages that system's trust relationship to reach a better protected real target. Walk the example on screen. System A trusts System B. System B is poorly protected, so the attacker compromises B first, then uses B's trusted relationship to pivot into A. In port redirection, a compromised system becomes a base for attacking other targets. Walk the example on screen. The threat actor SSHs into compromised host A, then uses host A as a relay via telnet to reach host B, which trusts host A. The compromised system does the dirty work of reaching the real target. In a man-in-the-middle attack, the threat actor positions itself between 2 legitimate parties to read or modify data in transit. Walk the 4-step process on screen. The victim's request gets redirected to the attacker. The attacker retrieves the real page from the legitimate site, can alter it, then forwards the possibly altered page to the victim, who has no idea anything happened. DOS attacks are the most publicized and among the hardest to eliminate. They consume system resources to block legitimate access. Contrast on screen. DOS, single source, relatively simple even for an unskilled attacker, versus DDoS, multiple coordinated sources, a botnet of zombie hosts, directed via a command and control program, much harder to trace and block than a single source attack. Securing a network means securing every device, routers, switches, servers, hosts. Most organizations use defense in-depth, multiple layered devices and services working together rather than relying on any single safeguard. The diagram shows a campus topology with a VPN router, firewall, IPS, email/web security appliance, and AAA server all working in layers. Backing up device configs and data is one of the most effective loss prevention measures. Infrastructure devices should have their configs and iOS images backed up to an FTP or similar server. 4 considerations shown in the table. Frequency, full backups monthly/weekly, partial backups more often. Validation, always test restoration. Storage, off-site per security policy schedule. And security, strong passwords protecting the backups themselves. Staying current with security updates leads to a more effective defense. As new malware emerges, antivirus definitions and patches need to keep pace. The most effective worm mitigation is downloading OS vendor security updates and patching every vulnerable system. Best long-term solution. Configure automatic updates with 0 user intervention required, removing the human factor from patch management entirely. AAA is the primary framework for access control on network devices, shown on screen. Authenticate who's permitted on the network, authorize what actions they're allowed to perform, and account what did they actually do. The credit card analogy on screen maps cleanly: identity check, spending limit, and monthly statement. A firewall is one of the most effective security tools. It sits between networks, controlling traffic and preventing unauthorized access. Key default behavior on screen. Traffic starting inside the network can exit and return freely, but traffic originating outside trying to initiate an inbound connection is denied by default. This asymmetry is the whole point of a firewall. 4 firewall techniques shown in the table. Packet filtering, based on IPMAC addresses. Application filtering, based on port numbers/app types. URL filtering, based on specific URLs or keywords. And stateful packet inspection, or SPI. Incoming packets must be legitimate responses to internal requests. Can also recognize and filter DOS-style attacks. Modern firewalls typically combine several of these. Firewalls can also allow controlled outside access to specific services. Servers that need external reachability, like a public web server, usually go in a DMZ, demilitarized zone, a separate network segment where the administrator can apply distinct policies. The diagram shows outside traffic reaching the DMZ web server directly, but never touching the internal trusted network. An endpoint is any individual device acting as a network client: laptops, desktops, servers, phones, tablets. The on-screen line captures the real challenge. The hardest part of endpoint security isn't the technology, it's the people. Well-documented policies plus employee training, matter as much as antivirus software and host intrusion prevention. More comprehensive solutions rely on network access control. New devices ship with default security settings that aren't always adequate. Cisco's AutoSecure feature helps automatically harden a router with the AutoSecure command. Though, as the on-screen warning notes, it enhances security without making a device absolutely resistant to everything. Broadly applicable steps regardless of vendor: change default credentials immediately, restrict access to authorized individuals only, and disable unnecessary services. Standard password guidelines on screen. At least 8 characters, 10 plus preferred. Mix upper/lowercase/numbers/symbols/spaces. Avoid dictionary words and personal info. Deliberately misspell words. Change passwords regularly. Walk the weak versus strong examples. Secret, or Bob 1967 feet, are trivially guessable, while B67N42D47F, or symbol mixed strings, resist brute force much better. Useful Cisco trick. Leading spaces in a password are ignored, but spaces after the first character are not, which enables passphrases. A phrase like "My dog Max loves 3 walks daily" is both easier to remember and dramatically stronger than a short, complex-looking password like T0Y0TA. The on-screen takeaway: longer beats cleverer. 4 hardening commands walked through on screen. Service password encryption encrypts all plaintext passwords in the config. Security passwords min length 8 rejects short new passwords. Login block for 120 attempts 3 within 60 locks out login attempts after repeated failures. And exec timeout 530 logs out idle sessions automatically. These directly build on commands from Module 2's basic device configuration. Telnet transmits everything in plaintext, including passwords. Medig photos/SSH should always be used instead for secure remote access. 6-step process shown in the table. Configure a unique hostname. Set the IP domain name. Generate an RSA key, 1024-bit minimum recommended. Create a local username/password database entry. Authenticate VT lines against that database, and enable inbound SSH on the VT lines. Full worked example putting all 6 SSH steps together on R1, shown on screen. Hostname, domain name, RSA key generation, username with secret keyword, MD5 encrypts that password, VT line configuration with login local and transport input SSH. Note: a larger RSA key modulus means more security, but slower encryption/decryption, a real trade-off to be aware of. Routers and switches ship with various active services that aren't always needed. Disabling unused ones both preserves resources and closes potential doors for attackers. Walk the example on screen. Show IP ports all reveals what's listening. Then no IP HTTP server disables insecure HTTP and transport input. SSH restricts VT access to SSH only, disabling Telnet. Close the module walking each bullet. The 4 threat types, 3 vulnerability categories plus 4 physical threat classes, malware types, and the 3 network attack categories. Defense in depth combining backups/patching/AAA/firewall/endpoint security, firewall techniques and DMZ isolation, and device hardening through strong passwords/passphrases, encryption, SSH over Telnet, and disabling unused services.